So what I want to talk about today is, first of all, just the overall status of the OPC UA working group and specification releases, and then more specific about some, let's say, IT connectivity work we did this year in a new working group called MQTT. And this like just shows you how we continuously improve OPC UA as an architecture, as a platform for communication. In general, this looks like planned. So we have like a 3-year release cycle since the first release, but that was just by accident. So there's not really, but it shows that to add bigger things and complete topics in the standardization just takes some time. And that's why I think 3 years is a proven cycle, at least in OPC UA. Since like till 104, we mainly completed and stabilized everything that was planned from the beginning in OPC UA. So a lot of that work is like clarifying little details that come up during certification, during product development. And the more products you have that have implemented OPC UA that are also tested, the more stable you get also with the specification. But we added like these erratas in between, very early, between releases. And then at the time where we had 104 completed, that was the first time where we added a big new feature, the PubSub functionality, that I will talk mainly in the rest of my presentation about, which like the MQTT part is also part of the PubSub extension. But we got more and more use of OPC UA in these companion working groups, and you heard, I think, about some of these activities from VDMA presentation. But there's also a lot of harmonization ongoing. So we try always to move features that are common as to a right level. And so VDMA is doing that, but we also have activities inside the OPC Foundation to harmonize and to move features into the right place. And some of that features need to go to the core specification of OPC UA. That's why we introduced this concept of amendment, so adding features between the major releases. And that was so successful that it killed us because we just got too many of them. So we said, okay, we need to go to a better handling of that. And so now we decided to include, especially to have a consistent set of these specifications and just one valid document so that you don't need to open the last spec release, amendments plus erratas. So we had always 3 documents in worst case that you have to look to. And we said, okay, we just include everything into like in a sub release. So clarifications, erratas, and feature enhancements go into these dot releases. And then we do have just a regular cycle of between 6 and 12 months to now have releases that we just push out. And if something is not finished, it goes to the next cycle. So a simple rule. And the current release cycle is OPC 10503. I have just 2 highlights here because there's also a lot of minor clarifications and minor features. But it's the first time we have the complete set of all parts of OPC UA on the 105 version. So the part 11 was the one that was still missing. And the MQTT enhancements and messaging, IT messaging enhancements that I will talk about in the rest of my presentation here. So the MQTT as a transport for OPC UA PubSub, but also JSON message mapping was already part of that 104 release. So we have that already since 5 years in the spec. The problem we saw is that a lot of if you have a new feature and products and component specs start to use it, you always get little things that you want to enhance, clarify, make better. And we had like most of this like use and enhancements were based on people from the OT world, especially like what Peter mentioned, like the field level communication initiative, brought a lot of input to that, but we missed dedicated IT knowledge and dedicated IT requirements, people that care just about the IT connectivity in that working group. So that's why we said, okay, we need to have like a specialized working group where we can get people in that don't really care about all the nasty details of all the OPC UA features. They care about the IT messaging. And that's why we said, okay, we start this new working group. And that was very successful because we got a lot of new people that are not really, they maybe know a little bit about OPC UA and they use it, but they don't really go into details. They are really mainly interested in the IT messaging. So that subgroup was started in end of last year. So the work really started early this year. And we have the first 2 outputs now in this new spec version that will go out most likely next week. There's more on the list, and I will, on my last slide, I will maybe give you some outlook, but that this is not, the work is not over. There's more on the feature list, but it's nothing of that is really breaking anything. It's just adding little things that make it more useful in the IT messaging scenarios. Just as the big picture. These are the OPC UA specifications. We have the core specifications. The blue ones is that we have already since a long time ago. In 105, we added several news. A lot of them are a split up of part 5. So the part 5 was going too big, and we extracted like the file management, the role management into separate specs. And we have this complete new set of OPC UFX specifications that Peter mentioned already. So this will potentially be a growing list here. But it's also part like of the core OPC UA set of specifications. Then we have this, like for example, the OPC UA for devices, which is also used by, I think, by a lot of the VDMA specifications, but also by OPC UFX. And in the big picture, like I said, this is the responsibility of the OPC Foundation to maintain and enhance this core functionality, including OPC UFX, including safety. And then we have the collaboration working groups to work on industry models or device machine-specific models. And this is typically collaboration working groups with other organizations. Okay, so if we talk about now more details of the PubSub and MQTT enhancements, the general idea of PubSub is that we have a complete decoupling of publisher and subscriber. So the publisher sends data to what we call message-oriented middleware, and that could be just UDP multicast addresses. So the infrastructure in this case is just switches, or could be an MQTT broker or any other message broker that we have a protocol for. And then the subscribers just subscribe on this known address in the middleware, and they receive the messages. The publisher doesn't know anything about the subscribers. Complete decoupling. So this stream of data and event messages, this is the main feature. But at the end of the day, you need also information about what is the content. So especially if we highly optimize the content, like in the binary format, for if you think about a motion control application, the engineers fight for every bit in the message. I would not even say byte. So we had in the working group when we did like this highly optimized binary representation, we really fight it for bits in the headers. And so if you have these highly compressed versions, you really need that metadata to understand what's in, what are the fields, what are the data types, but also additional information like if you have measurements, what is the unit? So in the energy area, it's if it's kilowatt or megawatt or gigawatt is a slight difference. So the unit matters. And that's all part of the metadata. So you typically are interested not only in the stream of data, you're also interested as a subscriber in the metadata. And then there's a lot of discovery information. What are available publishers? What do they send? What can I subscribe for? And in the MQTT mapping, we already defined like that you have a data topic and a metadata topic. It was always possible to really configure these topics for every data stream, event stream. But we didn't really have like a strategy for distributing discovery information or status information. We had that already for UADP and UDP, so for the peer-to-peer mapping. That's why I said in FLC, or in peer-to-peer communication, OT communication, we solved that problem already. But we wanted to have a symmetric resolution also for the MQTT case. So what we added now is a so-called standard topic tree namespace for OPC UA. And the main use case is for discovery. But you can also, like the data topics can also fit into that standard tree, but you can also still reference like other trees, custom trees for the data topics. But the idea is that at least the discoveries works with a known topic tree, and if you have the discovery information, then you also know where the data streams are located, so the topics for the data streams. So what is the definition we added is like we said, okay, we have this logic of building a topic tree, and there's a prefix, and the standard prefix is OPC UA. So if you do nothing else in terms of configuration of the system, this is the standard prefix. But you can have also like custom prefixes or also a hierarchy of prefixes, especially in bigger systems. I will give you examples later. Then we have the encoding. So we have JSON and UADP encoding. So both make sense I think if you have OPC UA aware application on all sides, UADP, the binary is much more efficient than the JSON. But we have also the JSON for, let's say, IT applications that have not really any OPC UA knowledge or no requirement to put on them. Then we have the message types. So we have the data is something we always had. Also the metadata message was already defined, but we added additional ones that we had already in the binary messaging. And now we have a definition for JSON, and we have a definition here in the topic tree where you can get them from. And that's status. That's if you're aware, like a little bit in MQTT, we use that especially for the last will and testament. Also, so the feature is that the publisher publishes its status, but if the publisher goes away, the broker can send on behalf of the publisher this testament message, last will message. On behalf of the publisher, so that the subscribers know the publisher is not longer connected to the program. Then we have application description. So this is like the same thing you get with client-server discovery. To say, so what is the product, what is the instance name, and capabilities of the application. Then we have the optional thing to say, okay, if the publisher is an OPC UA server, then you also get the endpoints for the server, and you can connect as a client, for example, to configure the publisher to maybe change the data that is sent through PubSub. And then you have on the connection message type, we have like all the information about the data streams that are configured for that publisher. And there you can also find then the data topic names. So if not the defaults are used, if you have custom configuration, you find there the custom topics also. Then we have the rest is like the identification of the publisher and some grouping inside the publisher for the data sets that are sent by the publisher. So just a few examples. So if you have like a just a local broker with the default prefix, and you send JSON messages. Then you have status of the canning line. So if the canning line is the publisher, this is the topic where you get the statuses from. Then on the connection topic, connection type, message type, you get like the information, what are the available data streams, data topics for that canning line. And then you have the specific data topic, the canning line, the filling station with the machine status is then the concrete topic that where you get like the data for the machine status from. And that's like one of the two examples I promised. So I think if you have set up like a local broker where you have like applications that talk to each other in a local network, maybe every device can have own publisher, and then the group, like the organization of the data is really inside the device that is the publisher. So you use the groups and the data sets to build a tree of the information, and then inside the data set you have the actual variables with the data that are set. So in this case, you have the default prefix, JSON data, and then just the organization inside the device as a subtree. Another example is where you have like this used in a bigger scope, maybe on an enterprise level or in a cloud environment. So in this case, you need to have like some top level structuring, like to have, say, okay, it's factory 2, hall 2, and then I have inside a publisher, I have maybe that's running on an edge device. I have a production line, and that's represented by the publisher, and then you have maybe information from a cell, and then the data out of that cell that is further structured. So in this case, you would use the prefix to do your basic structuring on the enterprise level, and then you can still use the structuring inside a publisher to further divide the data. The second topic, the JSON header layout, is I mentioned earlier that we need a lot of flexibility in our messaging formats in the payload to address like the use cases of having a cyclic high-speed communication for motion control applications, but on the other side, to have like IT applications that need maybe a different level of content in a message. And we, at the same time, it doesn't really make sense to have all these combinations randomly combined to create a message format. And that's why we already in the first release for the binary messaging, we defined already two default use cases with two default settings. So you just choose your use case, and then you get all the settings from the configuration tooling. But we didn't have that for the JSON, and that's what we added now. So we said, okay, we need the same concept also for the JSON messages to simplify and harmonize the layouts that are possible. And we defined 3 layouts, and the first one is very it excludes any additional OPC UA information or header information that you typically probably need. But if you have just a simple IT application that wants a name value pair list, and so what we call data set is typically a list of fields with names. Every field has a data type, and then value rank means is it a scalar or is it an array of values. And so in the simple case here with just scalar values, it's really a plain name value pair list. You have the name of the field and the value of the field. And in if you have like variables that are structured, so like this case, the coordinate is a structure with 2 values, and the measurement is an array of values. So in this case, you have then JSON objects like for the structure, or a JSON array for the array variable. So this is the simple one, and I think this is the one that is will be maybe the most popular one, especially for local brokers, for communication between applications in a local network or in a local environment, is you have one dataset message in a JSON object. So you would send that to one topic, and you have additional header information like identification of the publisher, timestamp, sequence number, so things you typically need for communication. The timestamp is typically important thing. Sequence numbers are important if you want to know if you missed something in between. So typically important, but like I said, this is the use case that we see if you really want to have a mapping of a topic to a data set. You would use this format. And then we have a third one, what we called a data set, a network message. And in this case, you can have multiple data sets in one network message. That the original main use case for that, if you have the topic is just used for streaming of different data to a cloud application, and there you have an application that's processing the messages and doing further handling of the data, of the information. In this case, you want to maybe combine that multiple data sets into one message and optimize that communication up to the cloud application. So that's, like I said, the third option. So now we have like the three versions that we expect as the 2 and 3, I would say, are the expected ones that are used typically in a MQTT broker environment. Okay, so the working group will continue the work. So what we're currently working on is commands for PubSub. So to have like in PubSub is not replacing client server. We just optimize like the information flow that is typically in a live system. So you have data that can be sent. You have events that can be sent, but in a lot of cases, for example, for job management, there's a lot of method calls. So if you also want to send commands over PubSub, we don't have a solution for that at the moment. So this is something we currently work on. So also Uni is involved. So if you want to get more live updates, you can ask also Uni. But like this is currently in work, but there's more on the list. And if you have requirements in this area, you're welcome to join the working group or to provide input. I had a discussion yesterday in Norway because people said, okay, we have requirements or we have ideas and we don't know how to solve them with OPC UA and PubSub. Then bring these requirements to the working group. And when we can either say, okay, this is already solved, do it this in this way. Or we say, okay, there's maybe a little thing missing to make it easier or better. Then we can add something, but we need to know your use cases and your problems with what we have today to make it better. So you're welcome to help or to provide input to the group. Questions?